Hi everyone, we are students of SPIT and are here for a presentation on phase 1 of our mini project. Next slide. Our topic of project is music generation using AI, where we'll be using the concept of deep learning. So I am Shubham Golwal and with me I have Vatsal and Kritik as my teammate and we are working for this project under the guidance of Anand sir. Next slide. Today, we'll be covering a problem statement, objective of our mini project, literature survey of all the research paper we went through, what is the scope of our project, the proposed architecture, what we are planning to do, the dependencies, and the references we refer to. Okay, so let us see what is our problem statement. What actually we are going to do. So in today's world, it's a myth that you need to be a music expert to generate music. Even a person who likes music can produce good quality music. We all like music, and if it's possible to generate music automatically, then it will prove to a new revolution in the world of music industry. Until very recently, all music generation was done manually by means of analog signal. In recent years, this has become possible with the help of AI and the concept of deep learning, especially generative deep learning. Overall, the goal of our project is to enable musicians, composer, and music enthusiasts to easily generate original music pieces while also pushing the boundaries of what is possible with AI and music composition using deep learning. Now, Kritik will take over.
Thank you, Shubha. So now let us see the objectives of our project. So there are five objectives. The first one, train an LSTM model on a dataset of MIDI files to generate new original music. Evaluate the quality of the generated music using quantitative measures such as note accuracy, rhythm consistency, and melody complexity. Explore the impact of different hyperparameters such as the number of LSTM layers or the size of hidden state on the performance of the model. Develop a web-based web application that allows users to input their preferred style or genre of music and generate a customized song using the LSTM model. Conduct user studies to access the appeal and perceive creativity of the generated music among different audiences such as musicians, music critics, and casual listeners. Next slide. So now let us take the look of the over the research papers that we have gone through. The first research paper was a study on application of deep learning algorithm and computer neural networks in automatic generation according to user style, which was published in 2021. So in this research paper, the it presents the use of neural network LSTM for AI music generation. It basically gives us the idea of how the LSTM model works. It explains the architecture of LSTM and briefs about the different activation functions. For example, the Sigmund function, the 10H function, or the ReLU function. 10H function solves the unicity problem. Sigmund function most is frequently used, and ReLU function solves the problem of gradient vanishing. It also explores the loss calculation for the network and two different choices for optimizers. The paper believes that LSTM network and Music 21 package have proved to be warranted and effective approach for digital music composition. So basically, the Python library of Music 21 is used in our model LSTM. So now Vatsal will continue further.
Okay, so the second research paper we referred to was a survey on deep learning methods for music processing. This research paper was published in 2022, which in this research paper divides music generation in mainly two areas: music information retrieval and music generation. MIR, which stands for music information retrieval, involves several audio analysis tasks, like which may include multiple pitch detection, duration estimation, instrumental identification, and onset detection. Also, after going through this research paper, it also covers comparison based on different architecture and their applications in MIR and music generation as well. Because of this, we got a comprehensive look on different algorithms like RNN, LSTM, GAN, and transformer. And also their applications like RNN is used for music generation, while style-specific music generation can be generated by LSTM, and symbolic music generation can be generated by GAN, and the recently used mostly used architecture is transformer, which is used for longer sequence generation. Now Watson will take over.
Thank you, Shubham. So, in this research paper towards music generation with deep learning algorithms, it mainly focused on the research neural network named long short-term memory for generation of musical sequences. This In this research paper, the group created a multi-layer LSTM neural network and feed-forward network, which was based on an acquired data set, and used an LSTM-based encoder-decoder architecture as baseline models. For the multi-layer LSTM network, they used three types of architectures: a two layer architecture which led to overfitting, so they uh, changed the architecture and used a three layered neural network, but that had too many silent pauses in the duration. So at final, the team decided on encoder decoder architecture, uh, and that provided a constant tone of several notes for the whole duration, and they decided on uh, using encoder decoder architecture. Uh, they also discussed the interpretation and the limitations of these models, and had a conclusion where uh, there is a need for further refinement before being able to generate actual music sequences. For the fourth research paper, we had an emotional symbolic music generation system based on LSTM networks. In this research paper, the team had used biaxial LSTM networks to generate a polyphonic music, and thought of look back is introduced into architecture to improve long term structure. The biaxial LSTM has input network layers like note matrix, pitch class, and pitch position, look back note matrix, and pitch class, and these are divided into several different layers. They adopted one hot emotion vector and as an additional input for generating emotional music. Uh, for their project, they have used four different emotions: happy, tensed, sad, and peaceful. They evaluated their model qualitatively by two metrics: musical metric, which included uh, parameters like polyphony, consistency in scale, tone span, and repetitions of notes, which are main characteristics in music theory. And they also had human accuracy. They also mentioned the human accuracy to classify the emotional categories, which had been overall came up to 60%. Now, for the market survey, our group has decided that once the model has generated a AI generated music sample, we would ask our users, group of people, to survey them and give their input on do they like the music, did they feel uh, that this music had a good quality or good sound. Now I would like Krutik to throw light upon the scope of work.
Yeah. So the scope of work consists of three topics: constraints, limitation, and assumptions. So let us talk about the constraints in our project. The quality and diversity of the training data will directly impact the performance of LSTM model. Limited availability or poor quality of MIDI files for specific music genre or style may result in low quality of generated music, which means that if we are having a poor quality of MIDI files or some corrupted file of MIDI in the training data, then it may lead to the uh, lower quality of the music generated. While LSTM model can generate new original music based on learn patterns, it may not have the ability to create music that is entirely new or never seen before, which means that the user may think that a part of it he has already listened somewhere. It is not something new. So that may be a limitation. Then the most of the three other three limitations are like lack of emotion, limited music styles, and ethical concern. So what is lack of emotion? The music is often used to evoke emotions in listeners, but AI generated music may not have the same emotional impact as human composed music. The limited music styles. AI generated music is often limited to music styles it has been trained on. So it may struggle in generating music in styles which is that is not been exposed to. Ethical concerns. As AI technology becomes more advanced, there are ethical concerns about whether AI generated music can be infringed on copyright laws or devalue the work of human musicians. Next, the assumptions. So the assumption that we have taken in our project are the preprocessing model can accurately extract relevant features from the MIDI file such as note duration, pitch, and velocity. So the features that are being extracted from the MIDI file should be properly extracted is the assumption. The LSTM model can learn the patterns and structures of the input music data and generate new original music based on those patterns. The MIDI files used for training and testing the LSTM are representative of the target music genre or style. Next slide.
So for the proposed
So now,
system, why we are using LSTM? So LSTM is a subset of recurrent neural network, and why we are using this subset, specifically this subset, is because for generating melodies have long-term patterns, and RNN fails to recognize these long patterns in the long run, because RNN has less memory space, and it cannot store up uh, input data for a long period of time. And because it cannot store the this data for long period of time, it faces two problems like exploding gradients and vanishing gradients. And LSTM helps us to recover from these problems. As you can see from the image shown here, LSTM has nodes. The green node is a node which has three types of gates: input, output, and a forget gate, which control the flow needed, and which is control the flow of input, and uh, this is needed to predict the output in the network. For in our case, for generating music using LSTM, we will give an amplitude as input, and we will record these amplitudes at a specific interval of time. And for the gates, we have different parameters according to our project, which will be pitch intervals, notes, chords, and tempo. For project planning, in the month of February and March, we were we had explored deep learning. We learned what is deep learning and different models included in deep learning. We had gone through various research papers and did literature surveys on them to find out which model is feasible, and different workings of models. For in the month of March, we are planning on implementation of model. For the month of April, uh, we are planning on building the implement working on implementation, where we would try to improve the accuracy and try to improve the model even further. In the week 3 and 4 for month of April, we will have a rigorous testing, and we would try to add more features and documentation and the cleaning of the code. And we have kept 1 week in May for buffer period in case there are delays in the previous weeks. For dependencies, I would like Shubham to uh, throw light.
Since our topic is ML based, so we are using Python on a large scale. So basically, we'll be building our model in Python, and we are using its library TensorFlow as well. We are also using Music 21 as a toolkit for processing MIDI files. MIDI files, which stands for musical instrument digital interface, which is a standard to transmit and store music. And then we're also planning to use MuseScore software for composing sheet music, and also where we could visualize the nodes of the music, and we'll be able to get musical notes there. Next slide. So now coming to the references, we have referred multiple research papers and we have did a literature surveys as well on them as we discussed earlier. We have also referred to blogs from Medium as well as some personal blogs, and this because of this blog we choose this topic as our mini project. Next slide. Okay, so that's it from our end. Thank you for your time.